make it look better. Okay. So a user will be able to put in some vectors here. So we'll say um, 30 newtons at 30 degrees or 30 degrees, and 100 and, let's see, 45 newtons or meters or whatever. It doesn't matter. This can be units. Magnitude can just be in units. At direction of 120, 60 magnitude at 213, and so on. Let's see, 32 at 131, just whatever. 45 at, there's 48 at, let's go something up in the 270 quadrant, 290. Okay, so the directions here are from north, always from north, and these are going to be the magnitudes. Okay, so what we want to do is we want to find the I hats and j hats of each one of these. Okay, that might be the first thing we might want to calculate. I hats and j hats. All right, so let's look at this for a second. Let's say we have a grid, and let's say we know a magnitude, because we have the magnitude. One, like the first magnitude is given, and we'll say the magnitude is, let's just say the magnitude is 1, keep it nice and easy. Let's say there's our vector, and the magnitude is 1. And we'll say it's at 30 degrees. 30 degrees, okay? So how would I find the I hat and j hat? Well, I would probably want to do sine of 30 times the resultant to get me this I hat, and to get the j hat, it'd be the cosine of 30, right? So it'd be 1 times the sine of 30 would be I hat, and 1 times the cosine of 30 would be my j hat in this case. So I'm going to take the sine of the angle times the vector magnitude, and that'll be my I hat. Now, what if the angle that is given is more than 90 degrees? So, like, it's down here. Let's say we have a magnitude, it was 1, and it was at 120 degrees. Okay, which means 90 and then 30 more. So this would be like 30. Okay, so how do I figure out what the I hat and j hat is? Well, I don't know if you've noticed this before, but you can always do sine for I hat and cosine for j hat if you use the entire angle. So, like right now, if you look at this, if you want to figure out the I hat and the j hat here, you might think, well, I'll take the sine of 30 times 1, the 1 times the sine of 30 here, would not give me I hat, it would give me this side, right? It would give me j hat. Okay, that'd be j hat. And 1 times the cosine of 30 would give me I hat right here. Okay, but if you take, remember this angle all the way down to there is actually 120. So if you take 1 times the sine of 120, that actually gives you the I hat. Okay, so really what you're doing is you're taking the sine of 120 all the way down to here, so you're doing this and this is what you're really doing. And the sine of that angle, 120, is the opposite right here, so it's actually I hat. And cosine of 120, 1 times the cosine of 120, 1 being just, I just made the magnitude to be 1. I mean, normally we don't do that. It's like 30 or 72 or whatever. So 1 times the cosine of 120 would actually be this side, j hat. Okay? So you don't need to figure out where your angle is, like in what quadrant for this. All you need to do is take the sine of the angle that's given, and that will be your I hat. So the sine of 120 times 1 is the same. What I'm saying there is the sine of 120 times 1, this one right here, is actually equal to 1 times the cosine of the other angle at 30. So the cosine of this angle here would equal that side, I hat, right? Well, the sine of 120 would actually equal the opposite side, which is still I hat. So, and this, you can use this for vectors in the future when you're doing vector problems. You don't normally need to, you draw 120, a vector in at 120, and usually we surround it with angles, and then we kind of do one of these angles. Well, instead, you could just take the sine of the big angle, and that'll work. That'll give you your I hat, and it'll give you your J hat. Let's think about it maybe this way. I could do this. I could do some vector of 1 unit at 45 degrees, and then I could do it at 135, right? Which would be another 45 degrees on either side, and then another 9 degrees from there, and 9 degrees from there. Okay, so this is 45. If I do the sine of 45 right here, right, I'm going to get the sine of 45 times 1. So that's why I did set the vectors to be 1, because I can just take it, the sine of the angle. Sine of 45 is 0.707. So that'd be an I hat. Sine of 40, or cosine of 45 is actually 0.707 also. Okay. All right. So if I go all the way around to here, that'd be 135. Well, if you want to check that, sine of 135 is actually 0.707. Okay. That'd be the opposite here. And the cosine of 135, if you do that, you'll see it's a negative 0.707. Okay, so I can just take the sine of the angle and have my I hat. Okay, so what about this vector here? That'd be 225 degrees all the way around. So this is 45. If I take the sine of 225, I will get a negative 0.707 I hat. If I take the cosine of 225, I'll get of course, a negative 0.707 J hat. All right, so if we go around a little bit more, I come up here, this angle would be 315 degrees. I don't have to divide this up into 45 and 45 and know what quadrant it's in. I can just take the sine of 315. The sine of 315 is a negative 0.707 I hat. The cosine of 315 is a positive 707 J hat. So all you do is take your resultant vector times the sine of whatever the angle is all the way from north, and you're fine. And that will be your I hat. Okay, so hopefully that's a little background and trig that'll help us with this. So we can come back up here, and let's go. I like to do all the calculations down here somewhere, and then drop the answers in up here. So let's go ahead and do I hat down here and J hat down here. Okay, so what would the I hat be of this first vector? Okay, so the tricky part, you could say, well, it's going to be equal the magnitude, which would be this cell, okay, times the sine of the angle, okay? The problem is that Excel does everything in radians. So when you're putting in 30 for your angle, and you're putting in 30 degrees, Excel is going to think you're putting in 30 radians. So what we need to do is we need to take our 30 degrees and make sure that it's in radians. So the way we would do that is we just put radians, and then we choose our angle. Okay. So that puts D4, that puts 30 degrees into radians. Now we want to take the sine of that. So we're going to come back out here in the front and we're going to do sine of radians D4. And hopefully that'll work. Okay. So, yeah, so the sine of 30. Okay, yeah. So we got C4 times the sine of radians D4, and that should be our I hat. So normally I could take 30 times the sine of 30 degrees, and the sine of 30 degrees we know is 0.5, so 0.5 times 30 would be 15. So that worked. Okay, and the j hat would be equal the magnitude times the sine of radians of, whoops, I messed up. That's going to be cosine. Sorry about that. I'm sure you're saying, I'm winging this. Forgive me. Okay, and let's go back here and make sure that's cosine. Cosine of radians of D4. Looks like I'm going to need another parenthesis there. Good, I think. Okay, and we'll come here and we'll, let's hit the little buttons here and go down a little bit. Okay. All right, so there's a I hat and a j hat. Okay, I should be able to drag this down, I believe. So we want 5 of these. 2, 3, 4. Does that work? C8 times the sine of radians D8. Okay, so that should work. Okay, and you can kind of see your I hats and j hats whether they're positive or negative. So in the first one, it's 30 degrees is in the first the upper right quadrant, so they should both be positive I hats and j hats. 120 would be in the lower right, so it should be a positive I hat and a negative j hat. 213 would be in the lower left quadrant, so they should both be negatives. They are. 131 lower right quadrant, positive and negative. They are. 290 is in the upper left quadrant. They should be a negative I hat and a positive j hat, and they are. So we're going to assume they're all correct here. Let's kind of fix our decimals here a little bit. Make them look. Let's just go to the tens place. And we'll go to the tens place here. Okay, so those are I hats and our j hats. So I could actually then come up here and fill them in, equals that. And I could drop those down like this, equals j hat. Drop them down like that. Okay. And then, of course, I would also want to sum these. So I could do equal, let's see, I think I can do sum and drag them all. I believe that'll work, right? I hope that was right. Equals sum and we'll fix the whoops. Let's go the wrong way on that. Fix the decimals on this too. So my this would be equals that, and this one would equal that. Okay, so I have an overall I hat and j hat, an overall I hat and j hat. Okay, so if I want to find the resultant magnitude here, then that's going to be pretty easy. I can do that right now. Resultant would be Pythagorean's theorem. So I'm going to equal this squared plus that one squared. And then I want to take the square root of that whole thing, right? So I'll put that whole thing in parentheses. And I will take it to the 0.5 power is one way to do it. You could do SQRT, I believe, also. So that should be our magnitude of resultant equals that. Okay. Sometimes the resultant can be 0. So, and you're supposed to print none in there if it is 0. So I might want to say if equals. Do if this cell. So you don't want to really kind of do equals 0 because sometimes it can be really, really close but not quite, and it'll look like it's 0 but it's not printing none. So I usually go like if that is less than like 0.01, then comma, let's see, print none, comma, otherwise go ahead and print that cell. That should work. So okay. All right. So let's we could try to test that. Let's go ahead and delete out some of the user information. Let's just do 3 vectors and let's have them be all the same magnitude. And we'll have them pulling all opposites. So we'll have one pulling at 0, one pulling at 120, and the other one pulling at 240. That should make a perfect triangle. And the resultant should be 0, and it is, and therefore it prints none. And then I need to come up here actually and do equals this one instead, B19. Okay, so if I change this a little bit to 70, then there should be a vector. Okay. All right. Hopefully that makes sense. We kind of have our, at least we have our resultant kind of figured out, depending on how many vectors I have. See, if we don't use all the 5 vectors, then there'll be some zeros there. Okay, I think I'm going to kind of stop that movie right there. Clearly we haven't done any of the graphing yet, so we'll work on that maybe in the next movie.